Hello and welcome. You're watching the Learn Electronics India channel. I'm Meghna, and in this video, we will be learning about the different components used in electronics. We will mainly focus on how we can identify the different components, how it is represented in a circuit, and the basic function of that component. Here is the list of components. So let us get started with the resistor. So whenever we use a resistor in a circuit, it means that it will oppose the flow of current in that circuit. So a passive component means that component will be using external energy. It will not produce any energy on its own. Whereas the active component, such as the battery, it will produce energy on its own. That stored energy it will be producing. Whereas resistor here, it will use energy or it will use voltage from the battery. So that is why we call it as a passive component. There is a dedicated video for resistor, inductor and capacitor. For now, we just have to understand that resistor will oppose the flow of current, and this is how we represent it. You can see the different colors on this resistor. So each of these colors mean a different value. So a total of these colors will indicate what is the amount of resistance that is being offered by that resistor, which we will be learning in a separate video. Next, we have an inductor. So in a circuit, this resistor, inductor, and the capacitor, which we will be learning next, all these three things will oppose something. While resistor opposes the flow of current, inductor will oppose the change in amount of current. And this component will also store the energy from the battery or energy from the source in the form of magnetic energy. So what happens is, if you can see these coils, so that metal coil is being wound around some core. So when electricity passes through this, magnetic energy gets induced, and that energy from the battery, some part of it will be stored in this. When we remove the battery from the circuit, at that time, this inductor will release that stored energy. It will not store all the energy from the battery, but only some part of it. And here you can see different ways of representing an inductor. We will mainly be using this for simple electronic circuits. If you know this symbol, it is more than enough. And if we give an arrow mark here, it means it is a variable inductor, which means its inductance keeps varying. Similarly, in a resistor, if I add an arrow mark like this, it means it is a variable resistor. Next, we have the capacitor. So again, capacitor also will store energy in the form of something, and it will also oppose something. So this opposes the change in amount of voltage, and it will store the energy from the battery, that is the electrical energy, in the form of electric charges or the electrostatic energy. These are the different sizes of capacitors. There are various types of capacitors which we will learn later. And basically, how a capacitor is designed is there will be two parallel plates, and between those two parallel plates is an insulator or a dielectric medium. Now, the way it will store the charges is, on one plate, all the positive charges will get stored, and on another plate, all the negative charges will get stored. So this plus symbol means that the positive charges will get stored here, and here negative charges. Similarly, this side also, it's the positive charges that will get stored, and here is the negative charges. Again, from the battery, this will store only some amount of electric energy. Again, after some time, this stored energy will be released by the capacitor. Next, we have the battery. So a battery will consist of two or more cells. And by cell, here we mean the electrochemical cell, which means there will be some chemical reaction happening. That is nothing but the oxidation and reduction. So what happens is, a cell is made up of different elements. For example, if you can see, this is a lead acid battery, And then we have the alkaline battery, but this is a nickel cadmium battery. Using different elements, a cell will be made. And when it supplies power or it is releasing its energy, that is because of the reaction of oxidation and reduction. So in one electrode, oxidation happens, and at another electrode, reaction happens. We have the positive terminal and negative terminal in a battery. And if you can see this symbol, the longer line is the positive terminal and the shorter line is the negative terminal. But here we also call it as anode and cathode, because these electrodes behave differently when it is releasing energy and when it is acquiring energy. So it's better we learn this as anode and cathode. A is for anode and K is for cathode. To put it simple, battery is basically the source. It is that device that supplies power to the entire circuit, and that happens because of conversion of the chemical energy into electrical energy. Coming to a switch, in layman terms, we say it as something that makes or breaks the circuit. So a switch is that component that will interrupt the flow of current in the circuit, or it will either divert the current flowing from one path to another path. If you can see this image, to these two terminals, we will connect the wires, and when it is on, it means these two wires that we have connected, they will come in contact, and when it is off, those two terminals will move away, creating an open circuit, and that's how it blocks the flow of current. This is a symbol of switch. Currently, this is an open circuit or the switch is off. To indicate that the path is closed, we will draw a straight line here. That instead of this slant line, we will bring a straight line here, which means that there is a switch and that switch is closed. Next, we have a fuse. Fuse is a kind of a safety device. So it protects all of the devices from overcurrent. If you see this image, inside there is a thin strip of wire. Now that wire will get melted when it is heated up, and it will get heated up because of the high current that flows through it. So when this melts up, it will create an open circuit and the current will not flow. Thereby, it protects all other components in that circuit. In our households, you might have seen this device. It is used at a point where the electrical connection to the home starts. So there, whenever overcurrent is there, this fuse will melt off. Thereby, it will protect all the important components and devices within the household. And this is the symbol of fuse. We basically use this symbol, the last symbol, but the other two symbols are also accepted. And this is a one-time use component. So suppose this melts off, we just cannot bring back that strip. So we have to entirely replace this fuse, but it is cheaply available, so it is still a good solution to use a fuse. Next component is the circuit breaker. What you're seeing in this image is a circuit breaker, and it is more like an advanced version of a fuse because it can be reused again, unlike a fuse. This is mainly used to protect the components from damaging because of a short circuit or also due to overload. So what happens is when such undesirable conditions occur, this blue color knob which we can see, it will trip off. So it will be on every time when the power is flowing through the components, and when such an undesirable situation occurs, it will turn off on its own, and we have to manually push it up or manually turn it on, and again it results in normal flow of current. And this is how we represent a circuit breaker in theory or in circuit diagrams. What exactly happens is, again, inside there will be a metal wire or a metal strip, and because of overload or because of short circuit, this metal, it gets heated up and it will reform its shape. So once it changes its shape, the closed contacts that will make a closed path, those contacts will move apart. And when they move apart, there will be an actuator which in turn will trip off this knob. Thereby, it will protect all other components. A very best example of where this is used is in our households. So in our home, there will be a common point from where the electricity supply starts. So at that point, you can see a circuit breaker like this. So whenever there is an short circuit, this will just strip off. Thereby, it protects all the important components in our home. And when you turn it on again, there will be normal connection or normal flow of current. A diode is a device that will allow flow of current only in one direction. This is because of the property of the material by which it is made. So diodes are made using semiconductors, and semiconductors have properties between conductors and insulators. So what happens is when we supply some amount of energy or some amount of power, then the electrons get activated and they start conducting. So this property is extensively used to design diode and also transistors, op-amps, and various other applications. While we will be studying about this in detail in a separate video, what we have to understand here is this is how a diode looks in real time. This color, somewhat grayish color, indicates that it is the cathode or the negative terminal, and this is the positive terminal. And this is how we represent a diode. This line indicates the negative terminal, and on the other side, it is the anode. Now, diode will conduct only when it is forward biased. What we mean by forward biased is the positive terminal or the anode of the battery will be connected to the anode of the diode, which means the cathode of the battery will be connected to cathode of the diode. That means it is forward biased, and only in that condition there will be flow of current through the diode. If it is the other way around, that is, if we connect the anode of the battery to cathode of the diode and cathode of the battery to anode of the diode, it is reverse biased, and in that case, the diode will act as an open switch or it will not allow the flow of current. Another way to say if this is forward biased is the voltage at anode should be greater than the voltage at cathode. Only then it allows the flow of current. This basic understanding is enough for now, and let us move on to light emitting diode or the LED. Again, LED is made up of a semiconductor, and another property is when we use different compositions of these semiconductors, different light is produced. So using that property, an LED is designed. So you can see components or the material that is used as gallium, aluminium, and indium. Using all these materials, an alloy is made, which is used in LEDs. So an LED has two terminals, anode and cathode. This is how we represent it. These two arrow marks indicate that that device will emit light. And this is how an LED looks in real time. The anode or the positive terminal will be little longer than the cathode. Or sometimes there will also be a slight bend on the anode side to indicate that it is anode. Now what happens is in this material, when voltage flows through it, the electrons and the holes. So electrons are the negatively charged particles in a semiconductor and holes are positively charged. So these two, electrons and holes, they recombine, and when they recombine, they release an energy. That energy is in the form of light energy, and that is why it emits the light and different color of lights because of the composition of the different materials used. This concept of recombination, electrons and holes, all these things we will study further in a dedicated video for semiconductors. For now, let us move on to LDR or a light dependent resistor. This is widely used to detect the presence of light. So what it does is, its resistance will increase or decrease depending on the intensity of light, which means this component, it will take in the presence of light, or it absorbs light energy. And that is the reason we have given an arrow mark into the component, whereas in the diode, arrow mark was coming out of the component, which means that emits light. But an LDR takes in light, and that is why arrow marks into that. So to a resistor, if I'm drawing two arrow marks into the resistor, it means it is a LDR. The concept is similar. So when light falls, the electrons that are present in the semiconductor material of this LDR, it will get energized. So once it get energized means there will be movement of electrons, which will increase the conductivity. So more conductivity means less resistivity, which means as the intensity of light increases, the resistance of the LDR decreases and its conductivity property increases. So this is the basic concept of LDR. It is used in applications where light is used as a deciding factor for the conduction of charges. A relay is also called as an electromechanical switch. So in the name itself, we can guess that the electrical energy that we give to the relay, it will be converted into one mechanical action. So that mechanical action here means it will either close or open the switch. So inside a relay, this is the image of a relay, and inside this there will be a coil. And when current flows through that coil, there will be a magnetic field. Now this magnetic field, what it will do is it will energize the switch mechanism, and that switch, depending on how we set it, it will either turn on or turn off. So this is widely used because it can be automized. So it can be used in places wherein we want the current to flow in two different directions, but there is a deciding factor that decides in which direction the current should flow. But for now, we just have to understand that when we pass electricity through this relay, and to these three contacts, we will be connecting the wires. So when an electricity is passed, that will be converted into mechanical action. So this is how we represent a relay. If you can see, this was for an inductor and this was for a switch. So this means a coil, and this is a switch, because relay acts as a switch. So that is how we can remember the symbols. Moving on to the potentiometer. So a potentiometer is a variable resistor, or we can say it as a manually variable resistor, because manually we can change the resistance in this potentiometer. So this is how a potentiometer looks, and this is how we represent it. So this arrow mark, it means that I can vary the resistance in this resistor, and that device is called as a potentiometer. Now it has three different terminals. One is called as the input terminal, to which we supply the input voltage. Another terminal is called as the output terminal or the signal terminal. This is connected to a wiper, and I can change the resistance value using this knob here. So it will be a rotating knob, and as I rotate it, the resistance of this potentiometer changes, which means to a circuit, this potentiometer will offer the amount of resistance that I decide by varying this knob. And the last terminal is known as the ground terminal, which will be connected to ground. This is all a potentiometer does. So the basic logic involved is internally there will be a resistor material, and as I move the knob, only some part of the resistor material will get connected to the circuit and the other part will not be connected. So if I further move the knob, further the resistance might either get increased or decreased based on the design of it. Next, we have a motor. Motor is a device that converts electrical energy into mechanical energy. If you are confused between a motor and a relay, please understand that a relay will convert the electrical energy into mechanical action, which is only the switching action. So it will either make the contacts or it will break the contacts. That is the only mechanical action a relay will do. Whereas a motor is used to perform different mechanical actions. The best examples are, if you can see in toy cars or any moving toys, it will have a small motor and it will help in rotating the wheels. So that is one action. And in real time, the water pumps that we have, this motor, the electrical energy that we give to the motor, it will convert it into mechanical action. But in this case, it is movement of water from the source to the tank. So like this, the mechanical action differs in a motor, and that is decided by the purpose for which we need to use a motor. This is a small motor, a basic DC motor, and the shaft here. So the toy cars or other toys that we have with a wheel, it will be connected to the shaft, and that shaft rotates. So in a motor, we have two main parts. One is the rotor, that is the rotating part, which is nothing but the shaft, and internally also it will rotate. And another one is a stator or the stationary part, which will not rotate. And the second image you see here, these are the gears. So these gears, they help in changing the speed of the motor to our desired speed. And this is how we represent a motor. Next is a transformer. As the name says, trans, which means it transfers the energy from one circuit to another circuit. There will be no conversion of energy, but there is just transferring of energy. And it uses the principle of EMI or the electromagnetic induction for this purpose. The main thing we need to know here is this represents one side of the circuit, or we can also call it as primary side. From this primary side, energy will be transferred to this side, that is the secondary side. So this secondary side will also be connected to some other circuit. But there is no connection between the primary side and secondary side. And this is where the electromagnetic induction comes into action. So when this side, it is supplied with voltage, this primary coil, it will receive that voltage and it will induce an EMF in this secondary side. And that EMF is in turn passed on through the other components in this circuit. Now, depending on our use, we can design this transformer to be a step up or a step down transformer. A step up transformer will increase the voltage from primary side to secondary side, and a step down transformer will decrease the voltage, which means the secondary side, the voltage will be less than the primary side in a step down transformer. Although both these parts are not connected to each other, they will be wound around a same core. So there will be a core. These two lines represent that core, and this primary wire and the secondary wire will be wound around that core that help in transferring of the voltage. Last two more components left, and now we have the connecting wires. Although this is a very simple component, it is very important, which helps in establishing the connection between the various components in a circuit, because direct connection of components would be difficult. So these connecting wires help us in connecting one component to another, which also closes the circuit. Now the properties of the material by which this is made, it will have high conductivity and low resistance. And it is designed such that the core material, if you can see here, this is the copper wire. Outside that, either it is made up of rubber or PVC, and it is wound around that so that human doesn't get in contact with those copper wires, which means these rubber windings, they act as an insulator. What you can see in this third image is the connector. So I can connect the wires to these connectors like this image. It is basically just used to join two different conductors and it will complete the circuit. So to make the process simpler, we use connectors. Last, we have an integrated circuit. So all the simple components which we learned before, be it the diodes, resistor, inductor, capacitors, others, that is put on a single board and it is made into a circuit that will perform different functions according to our needs. So that we call it as an integrated circuit. That board on which it is put is called as a printed circuit board. So everything will be inbuilt, the circuit and all those components that will all be fixed and the circuit will be made. We use it only to perform the functions that we decide. And this integrated circuit in turn is more like a raw material for various other components that we design. For example, the processor in a computer, and there is an amplifier circuits, or there are various other microcontrollers and microprocessor circuits that we use in day-to-day lives, which all have an integrated circuit as the fundamental component in them. So that was about the multiple components that we studied. To summarize, we have learned about the different components, the basic components that is used in electronics, and we have learned how we can identify that component in a circuit and also in real time. And we have understood the basic and simple functions of that component. For more information, you can visit this website. Hope you had fun learning. Thank you.